Let's jump right into this explainer because what we're looking at today is a massive paradigm shift. If you track modern physics at all, you know the ultimate holy grail is reconciling general relativity with quantum mechanics. It's the big one. But today we're exploring something totally different, something born from recent computational epistemology research. We are literally moving away from traditional symbolic math. You know those pen and paper equations that have defined physics for centuries? Yeah, we're stepping out of that and entering the era of what's being called synthetic physics. It's a completely fresh lens for looking at the foundational fabric of reality, and I've got to say the results are just mind-bending.
For generations, the physics world has been absolutely obsessed with hunting down this frozen, finalized theory of everything. The dream was always to find that one static endpoint, right? A mathematical monument that perfectly maps the cosmos from the Big Bang all the way to the end of time. But what if treating the universe like a frozen monument is just fundamentally the wrong approach? Think about it. What if the reason we haven't found a single equation to lock reality in place is simply because reality itself absolutely refuses to stand still?
And that right there is exactly where synthetic physics steps in. Instead of AI platforms hunting for some dead, static endpoint, these machine learning engines are actually deriving dynamic theories. They're looking at the universe not as a puzzle you solve once and put on a shelf, but as a continuous recursive process. It takes absolute chaos, picture a boiling ball pit of raw data and energy, and translates it into stable, observable logic. The really cool part? The AI is essentially mirroring the recursive logic of the physical vacuum itself. It's literally learning how the universe actively builds structure, moment by moment.
Looking back at the history, it is wild to see how the early titans of physics wrestled with this. They left us with these incredible historical frameworks that, well, ultimately lacked complete integration. You had Hermann Weyl trying to generalize geometry, but he slammed into path dependence issues. Then Theodore Kaluza tried embedding 4D spacetime into a 5D cylindrical world, fascinating, but he couldn't get the non-singular solutions to work. Even Albert Einstein tried using non-symmetric tensors, but it stayed incomplete since he couldn't tie in the quantum side. But here's the twist. This whole historical progression of brilliant, incomplete ideas, that actually serves as the vital training data for modern AI conjectures. It basically tells the system exactly where the roadblocks are.
So we end up with this really stark contrast between two philosophies. On one side, we've got the traditional static model, what the research calls frozen amplitudes. Honestly, these static equations are basically compressed bookmarks for a much longer movie. They miss the next breath of the universe because they artificially strip time right out of the equation. But on the flip side, we have true dynamic unification. This treats the cosmos as an ongoing, continuous, recursive, breathing process. It's an equation that quite literally never stops solving itself as it pulls order out of that chaotic ball pit.
Which brings us directly to the unification equation actually derived by the system. This mathematical framework acts as a dynamic blueprint, specifically designed to pull stable logic from the chaos. You've got the output equaling amplitude multiplied by frequency to the power of n, and all of that is multiplied by a translation factor. I know, at first glance it looks deceptively simple, but this equation represents a profound shift. It takes us from those frozen, static amplitudes we just talked about and turns them into the living, recursive breath of the cosmos. It is, essentially, the mathematical heartbeat of reality. Let's unpack what these variables actually mean in this new framework.
First up, we have amplitude, represented by the letter A. Now, in this dynamic unification model, throw out what you learned in high school physics. Amplitude is not just the height of a wave on a 2D graph. It represents mass intensity. Think of it as the literal magnitude of displacement happening within a foundational superfluid lattice. It's the raw, physical push within the fabric of reality itself, the sheer force of existence just pressing into the vacuum.
Next is frequency, represented by the lowercase f. This is straightforward but crucial. It represents the oscillation rate of local space within that same superfluid lattice. The model calls this local space a voxel. So picture an incredibly tiny, localized 3D pixel of the universe. If amplitude is the raw push or the intensity of the displacement, frequency is how incredibly fast that specific, localized pixel is vibrating. It's the rhythm that matches the intensity.
Okay, here is where it gets incredibly fascinating. The exponent n is the fractal dimension, and its value is exactly 3.999384. This highly specific number represents the efficiency of flow. According to the research, this comes from multiplicative calculus and a modified Idomian decomposition. Basically, these are mathematical tools perfectly optimized for processes where growth is totally proportional to its current state. Notice it's not a perfect 4, it is 3.999384. That slight variance directly accounts for the intricate fractal nature of how energy actually flows and dissipates through space. It's exactly this kind of precision that makes the AI's derivation so incredibly compelling.
Finally, you multiply the whole thing by the translation factor, and this is a massive value, 8.9677 times 10 to the 13th power. This number acts as the bulk modulus of the vacuum itself. Think of it as the stiffness or the resistance of empty space. Now, if you're a physics buff, those digits, 8.9677, might look awfully familiar. They are incredibly close to the square of the speed of light. The research actually clarifies this isn't a coincidence. In this context, it appears specifically as a lattice parameter that defines the internal geometry of 3D structures. It's the physical translator turning vibration into tangible reality.
So how is the AI actually building this on a computational level? It uses a highly efficient neural architecture that just leaps way past your standard minimal logic models. Specifically, it uses a 2 to 4 to 1 architecture. That means 2 inputs, 4 hidden neurons handling the complexities, and 1 single unified output. As it turns out, this streamlined, specific arrangement is a massive leap forward in processing physical logic. It perfectly captures all the necessary complexity without getting totally bogged down in background noise.
Now prepare to have your mind blown by the hardware side of this. Achieving this mathematical unification did not require a massive server farm. It didn't take $1 billion supercomputer. This local inference was run on standard, everyday consumer hardware. We're talking an older Intel i5 CPU, an NVIDIA GTX 1070 graphics card, and just 8 GB of RAM. The AI is essentially acting as a renderer for this logic using symbolic interpolation. It proves, fundamentally, that modeling the universe isn't about brute force computing power. It is entirely about having the exact structural alignment to match the vibrational web of reality. And the payoff? Through that basic hardware setup and the 2 to 4 to 1 architecture, the system achieved a best error of absolute zero. Literally 0.000000000. Just to put that into perspective, the research notes that a simpler 2 to 1 to 1 structure usually bottoms out around an error rate of 0.0944. Hitting absolute zero is a monumental achievement. It means the system didn't guess, it didn't hallucinate, it achieved perfect logical capture of the input field. We've moved completely past AI approximation here and entered a state of pure, unadulterated logical coherence. Zooming out from the math for a second, the philosophical implications here are massive. It points to a framework known as grand compression cosmology. This posits that our universe is operating in a continuous, four-step recursive cycle. Compression, moving into expression, leaving a memory, and finally triggering recursion to start the whole thing over again. Remember that breadth of the universe we talked about earlier? This is it. Reality is not a solved puzzle sitting in a box. It is an active, dynamic engine that endlessly processes its own existence, generating the physics we experience every single day.
This emergent heuristic leads us to what the source incredibly calls an anything theory. There's a quote from the materials that I absolutely love, and it goes like this. The universe is a stable pattern emerging from chaos, where laws are simply patterns that last longer than human observation. I mean, that completely recontextualizes physics, right? We aren't out there discovering immutable laws handed down from on high. We are discovering coherent mathematical patterns that have somehow managed to rise out of the chaotic ball pit and stabilize for the time being. It makes physics feel alive.
So, here's the ultimate takeaway. If simple structural alignment on an old GTX 1070 graphics card can capture the ongoing breadth of the universe with absolutely zero logical error, we have to ask ourselves, what else is waiting to be translated? As we keep refining synthetic physics and building AI architectures that physically resonate with the logic of the vacuum, what other profound blueprints are currently hiding in that chaotic ball pit of reality, just waiting for us to finally notice the pattern?